You ever stop and wonder what actually keeps planets spinning in orbit? Or, what makes a soccer ball fly when you kick it? Well, today, we're going to pull back the curtain on the elegant, powerful rules that basically run the entire universe, all thanks to Sir Isaac Newton. So, let's dive right in.
Okay, picture this. I'm sure it's happened to you. You're driving, you have to slam on the brakes, and everything on your passenger seat, your wallet, your phone, everything just goes flying forward. So what's going on there? It's not magic, it's pure physics. And the answer is hiding in three fundamental laws of motion.
But hold on. Before we can really get into the laws themselves, we got to make sure we're on the same page about two key ingredients that make everything else make sense. We're talking about force and motion. All right, first up, force. It sounds complicated, but it's really not. Think of it as just any kind of push or pull on an object. Seriously, that's it. When you throw a ball, that's a push. When you pick it up, that's a pull. Simple, right? So when a force gets involved, you get motion, which is really just a fancy way of saying something changed its position. And to get a little more specific about that motion, we use a couple of terms. There's velocity, that's just its speed and the direction it's going. And then there's acceleration, which is any change in that velocity, like speeding up, slowing down, or even just turning a corner. Okay, so here's the deal. Forces are what decide if something moves or not. If the forces are balanced, think about a book just sitting on a table, nothing happens, no change in motion. But when those forces are unbalanced, that's when the magic happens. That's when things start to move. So remember that. Unbalanced forces are the real key to understanding all this stuff. All right, now that we've got those basics covered, we're ready for the main event. Let's tackle Newton's first law. I like to call this one the law of laziness, because it's all about how things just kind of want to keep doing what they're already doing. So here's the official version. An object at rest is going to stay at rest, and an object in motion, it's going to stay in motion at the same speed and in the same direction, unless some kind of unbalanced force comes along and messes things up. And this whole resisting change thing, it has a name: inertia. Every single object has it. And the more mass something has, the heavier it is, the more inertia it has. It just makes sense, right? It's way, way harder to get a heavy bowling ball moving or to stop it than it is to do the same with a little balloon. Here's a super simple way to think about it. Imagine a soccer ball just sitting on the grass. That's the first part of the law in action. It's at rest, and it's perfectly happy to stay at rest forever. Until that is an unbalanced force, your foot, comes along and kicks it. Then its situation changes. Big time. And this brings us to a really cool example of inertia. You know that classic magician's trick, pulling a tablecloth out from under a bunch of dishes? That works because of inertia. The dishes want to stay put. If the magician is fast enough, the pull on the tablecloth doesn't have enough time to overcome the dish's inertia, so they just stay there. And hey, this is the exact same reason your wallet goes flying in the car. The car stops, but the wallet's inertia makes it want to keep moving forward. Okay, so law number 1 tells us that you need a force to change motion. Simple enough. Now, with law number 2, we get to find out how much that motion is going to change. This is where things get a little bit mathematical, but don't worry, it's awesome. So, the second law is all about the relationship between three things: force, mass, and acceleration. Basically, it says that how much an object accelerates depends on two things: how much force you apply to it, and how much mass the object has. The more force, the more acceleration. The more mass, the less acceleration. And all of this is wrapped up in one of the most famous equations in all of science. F equals ma. Force equals mass times acceleration. It's so simple, but this little formula is insanely powerful. It's a true cornerstone of physics. And this example just makes it totally clear. Think about throwing a baseball. It doesn't have much mass, so you don't need a ton of force to get it moving fast. But now, what if you wanted to throw a heavy cannonball at that same speed? Whoa, you'd need a ridiculous amount of force, right? More mass just means you need more force to get the same acceleration. All right, on to our third and final law. This one is really elegant because it shows us this beautiful symmetry in how forces work. And the big idea here? Forces always come in pairs. You've definitely heard this one before. It's probably the most famous of the three. For every action, there is an equal and opposite reaction. What that really means is that if you push on something, that something pushes back on you with the exact same amount of force, just in the opposite direction. Always. So yeah, let's just hammer that home. You have an action force. And you have a reaction force. They're a matched set, a pair. You can never, ever have one without the other. This is actually how a rocket gets to space. The rocket engine powerfully pushes hot gas down. That's the action. And in return, that gas pushes the rocket up with an equal and opposite force. That's the reaction, and that's what sends it flying. And it's not just for rockets. Think about swimming. Your hands push the water backward. That's the action. And what happens? The water pushes you forward. That's the reaction. It's the same thing when you walk. Your feet push on the ground, and the ground pushes you forward. This law is responsible for so much of the movement we see every day. Okay, so let's put it all together now. These 3 laws aren't just 3 random rules. They work together as a complete system, a toolkit that lets us understand and even predict how pretty much everything moves in the world around us. So, if you're going to remember just a few things, what should they be? Okay, here we go. 1, everything has inertia, that built-in laziness to resist change. 2, you need an unbalanced force to get anything to change its motion. 3, how much something accelerates is all about force and mass. That's our F equals ma. 4, forces are never lonely. They always come in equal and opposite pairs. And finally, number 5, these rules aren't just for Earth. They apply everywhere in the universe. Pretty cool. And that about wraps it up. But in a way, it's just the beginning, because now you know the rules of the game. So I'll leave you with a question. As you go about your day-to-day, where are you going to spot these laws in action? Because I promise you, once you start looking, you'll see them absolutely everywhere. Thanks for tuning in.